Welcome back to digital class, and now we are looking at this question together. Here said that Chloe set up two electromagnets using identical batteries in working condition. Means that both batteries are working and the wires and the iron bar P and Q are shown as well below. A steel nail is freely suspended at an equal distance between electromagnet X and Y. So freely suspended is basically it's just hang in there and just leave it like this. Okay. Now when Chloe close both switches, now when they use the word close both switches, basically means that there's an electrical flow. Let me just write the word. There is electric flow. Okay, P and Q. At the same time, the steel nail move towards iron bar P, then Q. It means that this move towards this side. Now, when it moves toward this side, and we know that there's nothing that's affecting it because both are working, it's working, and you can see both are with the same number of batteries, but it moved towards P. So the first thing that we can make this conclusion is there's a stronger magnetism. It moved towards P means that P have X lah, okay, I should say X means that it have a stronger magnetism. But why does it have a stronger magnetism? Because they have the same number of batteries, right? So what causes this stronger magnetism? Now this is something that we need to observe from here. Can you see that electromagnet X or the iron bar P actually has more what? More coils than Q, because here have more coils. And as you know, more coils, more or stronger magnetism. Okay, because the other factor is batteries, but they are having identical batteries and both have two. So the only things that are affecting here is the number of coils. So now A, give a reason why steel nail move towards bar P when P and Q switch on were close. Close means they connect at the same time. Why? Because bar P has more coils, which result in greater or stronger magnetism when the circuit is closed. That's all. That is basically a good answer. More coils, stronger, greater magnetism. Now let's look at the next part of the question. The diagram shows a part of a crane that uses an electromagnet. Now let me circle the word electromagnet to collect metal pieces for recycling. Now explain how the electromagnet of the crane is used to move the metal pieces in the sand to collection point W in the diagram above. So now the basic thing that you should always remember here is this crane is here to attract the metals, then this crane will move up to here, then drop off all the metal pieces here, and now you need to explain how this process actually works. Okay, so how do you explain this? So it might need more space, we can try. So when the circuit is closed, meaning there's an electric flow, right? The electromagnet will attract the metal pieces from the sand. Okay, that's the first part. You attract the metal pieces. Then the crane will move to the collection point W. And what happened here? It moved to W, then the circuit will be open. Therefore, the electromagnet will lose the force of attraction, and the metal pieces will drop at collection point W. Okay, so that's basically the whole idea here. When the circuit is closed, there's electric flow, the electromagnet able to attract the metal piece from the set. Then the crane will move towards the collection point W, and the circuit will be open, means that there's no electric flow. Then the electromagnet will lose the force of attraction, then the metal pieces will drop at collection point W. And that's basically the whole idea here. Okay, so again, that's why that we are using electromagnet here. Why? Because we can just make sure the circuit is closed, so that electromagnet have magnet to attract, and we can just off it, and the magnet will be losing the force of attraction. Because normal magnet is hard to lose the magnetic, right? We can electromagnet, we can just have the force of attraction and lose the force of attraction easily. Okay, that's why electromagnet is always better in the use of this separating. Okay, so that's all for this question, and thank you. See you. Bye bye.